Assalamualaikum warahmatullahi wabarakatuh. My name is Amira Nabila binti Abdullah. I will be presenting a topic of final year project on detection of petrol residues on the synthetic clothing as fire debris by using HS-SPME and GCMS. In arson investigation, it involves a procedure of evaluating the charring and residues discovered at the crime scene. Fire debris are apparent at the crime scene in the form of completely or partially burned by fire. Analysis of fire debris can provide leads to evaluate the cause of fire, as in most cases, the arsonist employed petroleum-based liquids such as petrol, diesel, and paint thinner to accelerate a fire. These ignitable liquids are composed of a complex mixture of volatile hydrocarbons. Because it has a high vapor phase, they are pretty efficient to be used as an accelerant. So, they are commercially available at any gas stations, and the paint thinner is easily accessible at a hardware store. Because of this, it is easy for the arsonist to acquire a fuel to burn a property without any restriction from the third party. Petrol is frequently used by arsonists in Malaysia to boost a fire. One case that can be referred is a fire blaze that was happening around 2017 at Darul Ittifaqiyah, in which the arsonist bought petrol from a nearby gas station and poured on bed that was placed at the main door of the dormitories. On top of that, clothes can be found as fire debris from the fire scene. It can be used as a material to ignite a fire as well. Previous researchers have conducted a study on clothes as a substrate in detection of ignitable liquid residues. In this study, head-based solid-phase microextraction is used as an extraction method to collect volatile fractions of fire debris and the petrol. It is reliable, simple, rapid, and non-destructive, as well as it is sensitive to volatile analytes. GCMS is also applied as a chromatographic technique to discriminate and characterize the volatile components present in the sample. This chromatographic technique allows an enhanced sample identification, and it provides a fast analysis time. In arson cases, fire naturally destroys almost all evidence, so there is low possibility to detect the remaining fraction of ignitable liquid present on the debris. Besides, the debris went through degradation and evaporation processes because, as we know, exothermic reaction releases heat and the volatile analytes from the ignitable liquids are evaporated in high kinetic energy. Besides, burning process can induce the partial pyrolysis of the debris, or in other words, it can produce additional volatile components. The significance of this study is that we can confirm if there is any overlap components present in the burnt synthetic fabric and the fabric that was combusted with the fuel. Besides, we can establish the time of survival of the accelerant retained on the burnt samples. The objectives from the groundwork are firstly to extract the volatile components from burnt synthetic clothing without accelerant and with the use of accelerant using HS-SPME. Second, identify any compounds within the burnt synthetic clothing using GCS. Third, to investigate the evaporation rate of petrol residues on burnt synthetic clothing by varying the time of extinguishing from 0 minute, 20 minute, 40 minute, and 60 minute. And fourth, to investigate the remaining fractions of petrol exits after burning the synthetic clothing at different periods. Many researchers from the past years have performed study on detection of ignitable liquid residues on various materials. As we can see from the figure, it is a pie chart of the percentage of the common submitted evidences from fire scene. It can be seen that carpets and padding dominate the data, followed by fabrics and papers as second highest submitted evidences as fire debris. In a study from Australia, the authors did a research on detection of gasoline residues on natural and synthetic textiles. It was found that the retention capacity in nylon and polyester fabrics are the highest compared to cotton and wool. Another study used polyester, cotton, wool, and silk fabrics as fire debris in a research. It was found that great amount of components from ignitable liquid residues are discovered and present in wool and silk samples for a longer period of time compared to cotton and polyester. For methodology, the chemicals and materials used are a fresh 195 petrol, nylon garment, polyester garment, a mixture of polyester and spandex undergarment, a lighter, metal tray, and glass vials. The synthetic garment sample, they were cut and were burned with petrol and without petrol. The ones that was burned with the petrol, the time of extinguishing was varied from 0 minute, 20 minute, 40 minute, and 60 minute before they are transferred into glass vials for extraction. The extraction method I choose is by using head-based solid phase microextraction, as we deal with volatile hydrocarbons in a various range of polarities, so we choose 100 micrometer PDMS polydimethyl as the fiber for SPME. For the standard petrol sample, the volatile fractions were collected at 15 degrees Celsius under water bath for 30 minutes, while for burnt synthetic garments without petrol and with petrol, the volatile analytes are collected for 15 minutes at 50 degrees Celsius. For instrumentation using GCMS, we use a capillary column HP5MS with 30 meter length, 0.25 mm internal diameter, and 0.25 micrometer film thickness. The carrier gas is helium at a flow rate 1 milliliter per minute. Injected temperature was programmed at 250 degrees Celsius, while oven temperature was set at 50 degrees Celsius for 5 minutes, then ramped up to 290 degrees Celsius at a rate of 20 degrees Celsius per minute and held at 290 degrees Celsius for 10 minutes. As for result, the detected components are compared in order to identify any overlap compounds that may be present. Firstly, nylon garment. There were no similar components that can be found on the nylon garment that was burned without petrol and on the same garment that was burned with petrol. However, when the nylon garment was combusted with petrol, the hydrocarbons detected are compared with the hydrocarbons that present in standard petrol. In standard petrol, there are up to 24 hydrocarbons that were detected, and these hydrocarbons are comprised of aromatic hydrocarbons, alkyl benzene, and alkanes. So, at 0 minute, 18/24 of volatile hydrocarbons are detected in nylon garment. At 20 minutes, 13 components are found. At 40 minutes, 9 compounds are identified, and after 60 minutes, only 3 compounds are discovered. At 60 minutes, only 3 components that are found. For polyester, there were 2 overlap components that are discovered from the polyester that was burnt with petrol and on the same synthetic clothing that was burnt without petrol, which were alkyl benzene hydrocarbons, 1-ethyl-trimethylbenzene and 1,2,3-trimethylbenzene. In investigating the evaporation rate of volatile fractions of burnt polyester with petrol, there were 16/24 hydrocarbons are found at 0 minute. There were 9 compounds are found at 20 minutes. 5 compounds are identified at 40 minutes and only 2 compounds at 60 minutes. For the mixture of polyester and spandex undergarment, there were no similar compounds that can be found when comparing the data from burnt garment without petrol and with petrol. By varying the time of extinguishing, there were 12 out of 24 hydrocarbons are found at 0 minute, 6 are detected at 20 minutes, 2 compounds are discovered at 40 minutes, and 0 compounds are found after 1 hour. From all these data, the remaining petrol fractions in the burnt synthetic garments are compared by using their evaporation rate. As petrol is high volatility ignitable liquid, it can be seen that the amount of petrol residues are decreased with time. As for conclusion, since we use petroleum-based fabrics, there were 2 alkyl benzene compounds, which are 1-ethyl-trimethylbenzene and 1,2,3-trimethylbenzene are found overlap in the burnt polyester garment without petrol and with petrol. Nylon shows the highest retention capacity of petrol residues after burnt and extinguished at 0 minute, 20 minute, 40 minute, and 60 minute. The analytical techniques applied in this study, such as HS-SPME, it is a reliable extraction method, and GCMS allows accurate characterization of hydrocarbons residues from the fire debris.